Hi guys, in this session you are going to learn about functions in SAS. Function definition is a function is a component that can accept arguments and perform operation then return values. And there are three types of functions in SAS. First one is a character function, and second one is a numeric functions, and third one is the date and time functions. Now we are explaining about the first one, character functions. Character functions are used to perform only on character data type variables. The syntax is new variable equals to function target variable comma arguments. For every function, syntax is same. The only change is number of arguments. The following are the character functions in that first one is substr. Substr is used to extract the string from a sentence. It means in a one sentence you can extract, it means you can separate that string from a particular sentence, and we write a syntax for that. And syntax is new variable equals to function target variable starting position of the string and number of alphabets from that starting position. Now we write example program for that. Data demo set SAS help dot cars edit is a new variable equals to substr is a function and make is a target variable here, and 1 is a position of a number and 2 is the number of alphabet from that, and run. Before opening data set log is clear, and we are opening demo. Here make our is target variable and the starting position is 1. It means it starts from A, and the number of alphabets are 2. It means AC in every observation. Here AU and here BM. And whenever you create a new variable, it will be created at the end of the data set, and that is named edit, and the starting position is a 1 and the number of alphabets are 2. That's why here only we get AC from a make variable. Like this you can extract a string from a sentence, and you can also replace a string by using substr. Then how it will be? And remember the data set substr1 a equals to math. Here a is a variable, math is the word in it, and substr is a function, a is a target variable, and 1 is the starting position, and 3 is the number of alphabets from that position, and equals to che. It means 1 is the starting position, it means it starts from m, and number of alphabets are 3. In this MAT, it is replaced by the CHE. This is our code, and put a run. Before opening dataset, log is clear. str1 CHETS. We are creating maths MATHS. Instead of MAT, it is replaced by the CHE. Got it? Like this, we can replace a string in a word or a sentence also. Now the second one is scan. Scan is used to extract a word from a sentence. Now the syntax is new variable equals to function target variable and word number in a sentence. Now we are writing an example program for that. I named the dataset scan, and a equals to, this is my SAS class, this is the sentence, and a is the variable here, and b is the new variable, scan is the function, and a is the target variable, and 3 here is the word number in a sentence. It means what is the 3 represent? Here this is the 1 word number, this is the 2, this is the 3. From this code we get in a B is 3. Log is clear. Then this is the sentence, and the third word is my. We are getting my in the new variable. Like this we can extract a particular word by giving its number in a code. For example, if you have a large sentence and you need a word in the reverse, it means at the end of the sentence. At that situation, you can't able to count from the starting position, and we can easily simplify by the minus symbol. Then how it will be? And I named the dataset scan1, and this is our sentence. This is my class session, and b equals to scan is our function, a is the target variable, and -2 run. Here what is this minus represent? Simply this minus represent from this end position. It means this is the -1, this is the -2. According to the code, we are getting in b variable class. We are running this code. Before opening dataset, log is clear, scan 1. This is our sentence. This is we get from -2. It means this is the session is the -1, class is the -2. That's why we are getting class here. Like this, we can extract a word from the end side also. And the next one is, if the sentence is separated with a special symbol, then how it will be? Data scan2 and a equals to this equals to, here equals to symbol is a special symbol. At this situation, how we extract a word from a sentence? Here b is a new variable and scan is the function, a is the target variable, and 3 already we know in a scan we represented the word number. Here is the 3. Now simply the special symbol is written in a code and runs. If you not give this special character in a code, it will be thrown an error. Now this is the error free. Now we are opening scan2. Here we are giving the word number 3 and it have a special symbol also. Here you try to give without a special symbol in the code, you definitely throw an error. Now the next one is compress. Compress is used to remove the spaces between the word in a sentence, and the syntax is new variable equals to function and a target variable. Here we don't have any arguments in it, and I named the dataset compress, and this is my class session. In the between the words we have a spaces. Now the b is the new variable and compress is our function and a is our target variable, and run. We are running this code, log is clear, and we are opening compress. And the created variable is with the spaces and the new variable without spaces between the words. By using a compress, we can remove the alphabets from a sentence. Then how it will be? I named the dataset with the compress one, and a equals to this is my class session, and compress is our function, and a is our target variable, and in the code whatever alphabet we need to remove from sentence, that will given in the code. Before opening dataset, log is clear, and compress. Here in the new variable there is no I. Why? Because we are given I in the double quote. Like this, we can remove a particular alphabet from a total sentence wherever it is. Like this, we can remove a more than one character from a sentence also. Then how it will be? And I named the dataset compress2, and the same example of variable a, and b is our new variable, compress is our function, and a is the target variable. And just like IAS, it means wherever IAS in the total sentence, the total 3 alphabets are removed from the sentence, and run. Before opening dataset, log is clear, and compress. Here the total IAS are removed from a sentence. Like this, we can remove alphabets from a sentence by using compress, and we can separate alphabets and numbers from a sentence also. And one is clear here, the sentence is in the character data type only. And for explain that, I am writing one code data set here, I named the dataset with a separate and created names variable with the numbers and alphabets in it. Now I named the dataset check1. It's separate. I created another variable C here, and K1 is a new variable, and compress is a function, and names is our target variable, and here double comma is a must and should, and D. Here D represent remove digits. It means it plays characters. And then another new variable K2. Compress is our function, and names is our target variable, double comma must and should. Next one KD. Here KD means keep digits. It means it removes the alphabets. And the next one K3 is another new variable. Compress is the function, and C. Here C is our target variable, and AB is our removed string from a sentence, and S is removed string from a sentence, and run. We are running this code. Log is clear, and we are opening check1. Here names is our created variable, C also created variable. K1 is a D for remove digits. It means it plays alphabets. And K2 KD, it means keep digits. It means it removes the alphabets. And K3, it removes the string. Have you got it? Don't confuse here. K1D, remove the numbers, remove the alphabets, keep digits, and remove the string. Like this we can perform different operations by using compress. And the next one is a compel. The syntax is new variable equals to function and target variable. Here also there is no arguments in it. And I named the dataset compel, and A equals to new variable. This is my slash session, and B is the new variable, and compel is our function, and A is the target variable, run. And log is clear. Compel. Here it removes all the spaces between the word in a sentence and gives one blank. Then what is the difference between compress and compel? Compress remove the each and every space between the word in a sentence, but compel it remove the space and give only one space between the words in a sentence. Next one is strip. Strip is used to remove the trailing space and leading space. I will explain what is the trailing space and leading space. And the syntax is new variable equals to function and a target variable. Here also it don't have any arguments in it. And I enabled the dataset trim1, A equals to space. This is my class session, and space. Here the space before a sentence is a trailing space. The space after a sentence is a leading space. Okay, now we are writing code. B is a new variable, strip is a function, A is a target variable, and run. We are running this code. Before opening dataset, log is clear, and we are opening trim1. Here A variable with the leading and trailing spaces, but in the B it will be removed both trailing and leading spaces. And then now the next one is cat. Cat is used to joining the two variables, and the syntax is new variable equals to function variable 1 comma variable 2. And I named the dataset cat set sash help dot cars. Again we are taking cars, and edit is a new variable, and cat of make and type run. In the cars dataset already we have a make and type variables. We are joining the two variables by one variable. Here log is clear. We are opening cat. Previously it have a make variable and a type variable. In the edit it will be joining two. Got it? Like this we can join two variables in one variable. Here when we applying cat, it is created with the spaces between them. Why? Because and this observation have a leading space and this observation have a trailing space. By the cat, we can't able to remove the spaces between these observations. Then what is the solution for it? Simply we can apply compress on it to remove the space while applying cat. And I named the data set cat1 set as help.cars edit equals to compress of cat. Simply compress is remove the spaces between the words in a sentence, and cat is a joining to variables. Okay, and run. Before opening dataset log is clear, cat. Okay, and already we have a make and a type variables, and edit is without spaces. Why? Because we are using compress. And the next one, concatenation. Concatenation is used to joining the two variable as like a cat, but by using symbols. Here we are not using any function in it. By the symbols we can joining the two variables. Then how it will be? And name the dataset demo1 set as help.cars edit 1 equals to strip of make. Then why we using a strip here? Strip is used to remove the trailing and leading spaces, and a pipe symbol. Between that pipe symbol we are giving double quote and strip type run. Here what is the difference between these two situations? In the cat, by using symbol. Simply in the cat we using just a cat function in it, and here without using cat function we just give a pipe symbol between the variables. Now we are running this code. Log is clear. We are opening demo, and simply make and type are the joining variables. At the end we are simply get by joining these two observation in a one variable, and here we have a one space between the two observations. And in this situation, if you want to space between the two observation in a variable, and if you want to any special character between that observation in a new created variable, then how it will be? And to need a space between, and I named the dataset demo2 set as help.class edit is our new variable, and strip of make is the variable here, and a pipe symbol and strip of type run. Here whatever you give between this space, if you give a space you get a space between these two variable observations, and if you give any special character instead of space, you get that special character between that observations in a new created variable. We are running this code. Before opening dataset log is clear, and I am opening demo, and this is the make variable, this is the type variables, and at the end we are getting space between these two observations. If you want any special character or any symbol between these two observations, simply you mention between this. And the next one, index. Index is used to find a position of a word or alphabet in a sentence. Syntax is new variable equals to function target variable target word or alphabet. If you give a target word, it gives the position of that word. If you give a target alphabet, it gives a position of that particular alphabet. And I named the dataset check set as help.class, and name one is a new variable, and index of name comma a. Here name index is a function, name is a target variable, and a is a target word, or here is a alphabet. And one more thing, it is a case sensitive. Before opening dataset log is clear, and I am opening check. Here target variable is a name, new created variable is a name one. What is the index give? It just give a position of a word. Here it is a case sensitive, that's why capital A is not considered, it's just a give a 0. 0 means you don't have that particular target where observation in it. And here the second position of a, that's why it give it 2. And here also the position is a second, that's why it's give a 2. There is a no a in it, that's why it's give a 0. Like this, it give a position of a particular alphabet or a word in a observation or a sentence. But in a real-time scenario, we are not using index like this. It means we don't need a position of a character or a word in a real-time scenario. Then how we use this index in a real time? In the real-time scenario, data check one sets as help.class. In the if statement, index of name, index is a function, name is a variable, a is a target alphabet and greater than 0. I will explain what is the greater than here. Then name1 equals to name. Here new variable is the name1. Then it will be name. And this condition is satisfied, then new variable will be created. Otherwise it not created. It means simply true. When we give a greater than symbol in this for this condition, if it is satisfied, then new variable will be created. If it is not satisfied, it means if you give equals to 0, it is not satisfied. Then name2 equals to name, and for not satisfied or false, right? What you understand here? Simply if it is greater than 0, then condition is true, name1 will be created. If it is equals to 0, it means if it is condition is false, then name2 will be created. Now we are running this code. Before opening dataset, log is clear and check one. Here name1 is a true. It means if that variable have a, then name1 will be created. If the variable don't have that small a, name2 will be created. Are you got it here? Here a is there. It means the first condition is true. Then variable is created name1 from the name. And wherever that condition is false, it means if you give equals to 0, equal is a false, it means not satisfy, and greater than is a satisfy, it means it is true. Got it? Like this we use the index function in a real-time scenario. And the next one is translate. Translate is used to replace the alphabet, and the syntax is new variable equals to translate variable replacement, whatever you want replacement, and the target. I will explain the code. Enable the dataset trans sets as help.class, and new is a new variable here, and translate is a function, name is a target variable, and what you want to replace xy, and what is the target ar, and you can use more than one alphabets also. Before opening dataset, log is clear, trans. Here new is our new variable, and wherever ar, it will be replaced by the xy. Clearly observe, here is the ar. Instead of a, it will be replaced by x, and instead of r, it will be replaced by y. And wherever a, here a is there, carol, and that a is replaced by x, r is replaced by y. And here jane is there, and a represent x, that's why only x is replaced. Okay, like this we can replace a string by another string. And the next one is transword, to replace the word. I will explain what is the difference between translate and transword. I give a syntax here, and syntax is a slight difference. In the translate, first it is a replacement, but in the transword it is a target. In the translate, second is the target. In the transword, second is the replacement. That is the syntax different. And here translate is used to replace the alphabets, and transword is used to replace the word. This is the difference between translate and transword. I am explaining the code for the transword. I named the dataset transword. Sets as help.class, and new is our new variable, transword is a function, name is a target variable, ar is a target here. Keep it in mind, the syntax is a different for translate and transword. Xs is a replacement, and you can use a more than x. Before opening dataset, log is clear, transword. Here wherever AR. Wherever AR is there, it will be replaced by the triple X. Only the combination of AR only. Are you got it? AR. Combination of AR only. What is the difference between this translate? Translate wherever A is there, it don't need the combination of words we give in the target or replacement. But in the trend word, it need a combination of target. Are you got it? The difference here. Instead of A, it is replaced by X. Wherever A is there, it is replaced by the X. Wherever R is there, it is replaced by the Y. But in the trend word, it need a combination of alphabets. It means it need a word to replace. Wherever AR combination is there, it means wherever the word is there, it will be replaced. Wherever alphabet A is there, it will be replaced. This is the difference between translate and transword. Observe the data sets also here. Wherever A is there, here there is a no AR. Only A is there, but it is replaced by the X. In the transword, here A is there, but it is not replaced. Wherever here AR is there, it will be replaced by the triple X. Got it? Like this, translate is replace the alphabet, transword is a replace the word. Now the second one is the numeric functions. Numeric functions are used to perform only on numeric data type variables. And the syntax is new variable equals to function and target variable in the bracket. The following are the numeric functions in SAS. In that, first one is int. Int function is used to give integer part of a decimal. Now we see the example for that. Data, I named the dataset name int, and a equals to 12.6 and b equals to new variable here, and int is the function and a is the target variable, and c equals to, directly we give some number, and then d equals to integer of c, and g equals to integer of directly 63.236, and run. Here what is the difference in it? If you want to give a variable, then directly you give a variable. Otherwise, you can give the direct value also instead of variable. Now we are running this code. Before opening dataset, log is clear. Here we give 12.6. Then b equals to integer of a. What it gives? It gives integer part of a number, and it's remove the decimal part of the number. It means it directly give integer of decimal numbers. Okay, c is the direct variable here, and we give d of c. That's why up to 63 we get in the d, and 0.36, this decimal 36 will be removed by the integer. Are you got it? Integer only gives the integer value of a number. And the next one is seal. It gives upper value. Then what does it mean? And I created a dataset. I named the dataset seal, and a equals to 12.6 and b equals to seal is a function. A is a target variable here, and a c equals to number, and d equals to seal of c, and e equals to seal of 632.36, and run. Here, by the same example, we change the function. Here the integer, it gives the integer value. It means neglect the decimal part of a number. Now we giving seal. Seal means upper value. Got it? Then how it will be? Before opening dataset, check log. Log is clear, and seal here. Here observe here. A equals to 12.6. Then what does it return? It returns 13. It means if a number after point is greater than 5, it adds to the integer. Got it? Here 12.6 is the A and B gives 13. By the seal we can get upper value. What does it mean upper value? Here 12.6. If the point after point is any digit is there, it's directly add 1 to the integer. It gives 13. Like this here 63.36 and after whatever number is there it just add 1 to the integer, then it gives 64. And here in the E we have 632.36 and 1 add to the 2, it gives 633. Like this the seal it gives the upper value of an integer. Just add 1 to the end number of integer. And the next one is floor. It gives lowest value. Okay, then how it will be, we check. And I named the data set floor. A equals to 12.6 and B equals to floor of A and C equals to number and D equals to floor of C and E equals to floor of 632.36. Again we are taking the same number for easy understand. Now we are running this code. Before opening data set, check log is clear and floor. Then what it gives? Simply it neglects the decimal part of a number just like an integer. That's why it's called as the lowest value floor. Got it? Whatever after decimal is there, it will be neglected just like an integer. It gives the integer value nothing but floor. Are you understand what is the difference between seal and floor here? By the in the integer the same result we get in the floor also. Observe at once 12 in the floor 12. In the integer 632 it just gave a 632 here. It means the process is different but the result is same in the integer and floor. Now the next one is round. Round it gives the nearest value of a number. Then what does it mean of realest value in the number? And I named the data set round and A equals to 12.6. Again we are taking the same example for easy understand. And B equals to round of A and C equals to number and D equals to round of C and run here. Before opening data set, check log is clear and round. Here observe clearly, here 12.6 is there. It means after point the number is above 5 and here after point the number is below 5. If the decimal part, if the first number in decimal is greater than 5, then it adds to the integer. That's why it's getting 13 here. If the first number in a decimal point is below the 5, then it will be neglected. Are you got it? In the round value, if the first number in decimal part is greater than 5, then it adds to the integer, just like here. If the first decimal point below the 5, then it will be neglected, just like an integer value. Got it? This is the round. And the next one, n. N gives non-missing values. It means whatever the values are present in it, it will be given by the n. Then how it will be? I named the data set n. And A equals to n of, these are the numbers, and run. We know that in the numeric the missing value represented by the dot. Here these are the missing values and these are the numbers. Then what it gives? Before opening data set, log is clear. Here it gives simply the number of presented values. It means 1, 2, 3, 4, 5, 6, 7. The number of values are present 7. That's why in the output it just give 7. This is an n. And the next one, n miss, it gives the missing values. It means simply what are the observations are absent in that particular variable, it will be displayed n miss. And a equals to n miss of we give a same number and run. Before opening dataset, check log is clear, and n miss. Here the number of missing values are 6. Let me count 1, 2, 3, 4, 5, 6. Like this, we get missing and non-missing values by the n and n miss. And the next one is sum. To do just a sum, and I named the dataset sum. A equals to sum of, we just give some random numbers in it, and b equals to sum of random numbers with the missing value. Then what is the difference between these two? We check by the result. And c equals to, directly we give, instead of use as a function, if you directly give a plus symbol also it gives the value. Then d equals to same, we check the result by the using function or directly by the numbers, and run. Before opening dataset, check log is clear. And what is the node? Missing values are generated. That's why, because we are giving a missing value, that's why it's a missing values are generated. Now the sum here in the a is a directly give 28, the total number of adding that numbers, and b gives 23, and c gives 28, and d gives missing. Or you understand here, if any missing value in the numbers, by adding plus symbol it doesn't work. By the sum function, it consider this as a 0 and adding the remaining numbers. That's why in a we are getting 28 and we minus 5, that missing value consider as a 0 and giving result. But by adding symbols it throw missing value. Or you got it? And simply, if there any missing values in the adding numbers, better to use sum function instead of using plus symbol. Now next one is lag. Lag brings one observation step down. Then how it will be? And I named the dataset lag. Set as help.class. Lag is our variable. Lag is a function, and age and run. Here lag is a new variable, and here lag is a function. Before opening dataset, check log is clear. We are opening lag. Here we are applying log on the age. That's why it one step down. Or you got it? Simply what lag do? It one step down in the observation, and the last will be removed from the variable. Or you got it? It one step down, last value will be removed from the variable. Like this, we can step down, one step down by using lag. Not only one step, we can, however the numbers want step down, we can easily apply by the code. And I named the dataset lag2 and set lag, and lag 1 equals to lag 4 of age and run. Here what is the difference between these two conditions? Simply I am just giving number here. By represent number, the number of step downs will be decided. Okay, now we are running this code. Before opening dataset, check log is clear, and lag 2. Here we are giving 4, that's why it 4 step down in the variable, and the 4 down observation will be removed from the variable. Like this, you can step down whatever number you want in the variable. And the next one is differ. Differ gives difference, and I named the dataset diff and set as help.class. Diff equals to, diff is a function here, and age is the variable, and diff 1 equals to difference of diff. Again we are applying diff, and diff 3 equals to diff of diff 1, and diff 2 equals to age minus height and run. Here what is the difference give? In a one variable, it differ by the upper variable. Okay, I will explain by the result. Before opening dataset, log is clear, and diff. Here in the diff, we are just giving age variable. That's why 13 minus 14 is a -1. Here there is a no upper value. That's why it's a missing. And here 13 minus 14 is a -1. And 13 minus 13 0. 14 minus 14 0. And here 14 minus 13 1. Like this, it will be differ to the upper variable, and just like this 0 minus -1 1, and 1 0 1 0 1 -1, and again here 1 minus 1 0. And we can also difference of the variables age and height. 14 minus 69 minus 55, 13 minus 56.5 43.5. Like this, we can differ in a one variable of the observations, and we can also differ two variables. Like this, differ function will be work on the variables. And the third one is the date and time functions. Date and time functions are used to perform only on date and time data type variables. The following are the date and time functions. That first one is DHMS, and what does it do? Adds up date, hour, month and second to the date. Okay, then how it will be? I named the dataset DHMS, and A equals to 1 January 1989. And while creating a date variable, must and should give D. If you give D only, it consider as a date. Directly if you give this date, it doesn't consider, it just consider as a character. Keep in mind, it's a very important while creating a date variable. Got it? While creating a date variable, must and should add D at the end. At that situation only, it consider it as a date. Now we add our month, seconds to this particular date, and B equals to 15, C equals to 30, D equals to 15. It means 15 hours, 30 minutes, 15 seconds. And DA2 is a new variable, and DHMS is a function. Date, hour, month, second, and A, B, C, D. A represent date, and B represent hours, C represent time, C represent minutes, D represent seconds. And the just next one, DHID, DHMS, and simply instead of giving variables, if you give direct observations like this, it's also take the same. Okay, and I give a format to all the variables and run. Before opening dataset, check log is clear. DHMS A, B, C, D. In DTID2, just it convert as a date and time observation. In the middle it gives D, we call as a ISO 8601 format. And the next one, without variables, if you give directly observation between the date and time, it doesn't represent with the T. This is the difference by directly applying by the observation and directly apply by the function. And while creating a date and time observation like this, T is the must and should between the date and time. So it's a better to create by the function. And the next one is MD by, to create a date by month, day and year. And I named the dataset MD by. M equals to 1, D equals to 12, and Y equals to 2013. And A is a new variable, MD by is the function, and M comma D comma Y, and I gave a format to the A. Simply we are creating one date here, and before opening dataset, check log is clear. MD by month, date, year, by these three we are getting a date. Like this, by the mdy you can create a one date. And the next one, int ck. Int ck, it gives difference between two dates. Got it? It gives the difference between two dates, and data set name is an int ck, and a equals to 19 June 2017. D is the must ensure while creating a date, and b equals to another date, int ck y. Okay, and int ck is a function and year of a comma b. Then what it gives between a and b, it gives only year differences. Okay, next one, int ck m, int ck of month comma a comma b. It means it gives months difference between the two dates. And int ck d, int ck and day of a comma b, it means it gives days difference between the two dates. And format, I give a format for the two variables a and b. Before opening dataset, log is clear. Int ck. Here in the int cky, it gives the years difference between a and b. What is the years difference? Only 1 year, 2017, 2018. And int ckm, it gives the months difference between these two, June to June 12. And d gives days difference between these two variables observation. Like this, we use the int ck to measure the difference between two dates. And the next one is an int nx. It adds up two dates. Got it? Int ck is gives the different, int nx it's add, and I named the dataset int nx, and a equals to one. We creating a one date variable. While creating a date variable, d is the must ensured, and int nx y equals to int nx is a function, and here a comma 10 and same thing. Here we are adding year. How many years? 10 years. And what about date and month? Same day. It means we are not changing date and month. We are just adding 10 years to the variable a. And the next one, int nxm and int nx of month a comma 5 same day. Simply we are not changing the remaining ones. It means we are not changing the day and year. We are just changing the month, and we are adding 5 months to the same day. Got it? Same day means whatever you mentioned in the code, that will be changed, and the remaining two are the same. Here if you mentioned year, date and month are the same. If you mentioned month, day and year are the same. And the next one, int nxm1, and int nx is the function month a comma 4. Now if you are not giving the same day, then simply it's add direct months to the existing variable. Int nxd, int nx is the function days of a comma 10, and we are applying just format to the all and run. Before opening dataset, check log is clear. Int nx. Here in the a variable we are giving, in int nx we are just adding 10 years to the a and same day. Means of what? Date and month is not changing here, 19 June, 19 June, and only year is changed. Why? Because in the code we are giving same day. And the next one is int nxm. It means we are adding 5 months at same day. It means of what? Day and year is not changing, only month is changing. In the next one we are not mentioning a same day. Simply it adds 4 months to the month, and remaining also same. It just add 10 days to the month. 19 June, it just adding 10 days. Like this, int nx is used to add sub to dates like this. While practicing yourself to create your own examples. Please subscribe my channel, click the bell icon, like the video, and comment below, share with your friends. Thank you. Support me.